Sketch the graph of this function, which is a rational function with linear functions on top and bottom of the fraction. Well, the first step is always simplify. So I can't factorise the top, but I can the bottom. It's 2 negative x plus 3. Okay, there's no common factors here. There will be a discontinuity when x equals 3, because then the bottom of my fraction will be 0. So I'm actually going to use the method that I learnt, which is ideas, rather than the order in the textbook. The result will be the same. I'm just trying to provide you a framework that you can remember easily. So first, intercepts. For the y-intercept, let x be 0. And what have I got? Y is 7 on top over 6 on the bottom. For x-intercepts, set y equal to 0. Well, that's my function. 5x plus 7 over negative 2x plus 6. If a fraction is 0, oops, that was a bit of a mess. If a fraction is 0, then the top of the fraction must be 0. So that means 0 is 5x plus 7, and x is negative 7/5, negative 1.2. Okay, maybe I should write this down just to remind us what we're doing. Intercepts, discontinuities. Discontinuous when the bottom of my fraction, negative 2x plus 6 equals 0, i.e. x equals 3. Now, because that's on the bottom of a fraction, as we approach x equals 3, the value of my function, the value of the denominator is going to get very, very small. So the value of the fraction as a whole is going to get very, very large. So it's going to make a vertical asymptote. That's going to be a vertical asymptote. What's the function doing around that asymptote? As x approaches 3 from below, x is actually slightly less than 3. If x is less than 3, this is positive, and the bottom is going to be 6 minus something a little bit less than 6, so it's going to be positive. If x is greater than 3, approaching from this side, if x is greater than 3, then this again is going to be positive. This is going to be 6 minus something slightly bigger, so it's going to be negative on the bottom, and I'm going to be coming up to this part. Okay. Discontinuities. Extremities. Extremities. As x approaches negative infinity, what's happening to y? This is a bit tricky. Actually, I'm going to do this both at once, plus or minus infinity. I'm going to show you a little trick. Okay? This was my function for y. We're going to divide everything by x, by the highest power of x in the function. So y is 5x plus 7 over negative 2x plus 6. Well, if I divide that by x, I've got 5. This is 7 over x. This is negative 2. This is 6 over x. Now, why did I do that? Because as x approaches plus or minus infinity, x is very, very large. So this becomes basically 0, and this becomes basically 0. So as x gets very large, these two terms disappear, and I've got 5 over negative 2, which is exactly negative 2.5, negative 2.5. That tells me as my graph gets bigger at the outside edges, the y value is getting close to this value, but never quite going to reach it because these won't quite be 0. That means this is a horizontal asymptote. This trick works anytime you have the same power of x at the start of the polynomial on top and bottom. If they are both the same leading degree, then you can ignore everything else because of this trick and just look at those leading coefficients. And that gives you the horizontal asymptote. So what I need to decide is the function actually going to get to the edge on the side it already was? So getting here and here? Or is one of these going to cross the asymptote and then go back? Now, if both the top and the bottom of this fraction are linear, it won't cross the asymptote. Later on, you will find situations where it will, but I'm going to leave that for later. So for now, if they're both linear, then it's going to look like that. And all that remains is for us to try to figure out a few extra points so we can plot this accurately. We've actually now done intercepts, discontinuities, extremities, and asymptotes. I have found the two asymptotes already, vertical and horizontal. Are there any other special points that I want to know about? Well, again, because it's linear on top and bottom, there won't be any stationary points. I have already got the intercepts, so this is probably enough to sketch this graph. Let's try. Okay, what do we know? Y-intercept is 7 on 6, just over 1, 0, 7 on 6. The x-intercept was 7 on 5, here. Negative 7 on 5, 0. Thought I made a mistake there for a minute. All right, let's draw in the asymptotes. Use different colours as usual so we can see what's going on. X equals 3 is a vertical asymptote. I don't think that's any more visible than the green. Thought I would try the blue to see if it was better. I actually don't think it is. So that's x equals 3 is one asymptote, and y equals negative 2.5 is a horizontal asymptote. Y equals negative 2.5 is another. All right. We know the graph goes up towards infinity, comes up from infinity. We know the graph doesn't cross the asymptotes, so it must be doing that. I'm going to sketch this one in first because I have some information about where the graph goes. And the other one has to look the same, but a bit further out. From there, okay. If you want to be really precise, you can actually also pick a point over here somewhere, like 5 or 7 or something. Pick 1 or 2 points, evaluate the function at those points, and work out another point or two here. If you're not confident of getting it close enough, just by sketching it in. This really should be the same distance as this. For example, my graph is really probably a bit further out, but that's good enough. And we'll label it. Y equals 5x plus 7 over negative 2x plus 6.